Hello, welcome to our demo presentation on the Discovery plugin. In this demonstration, we will explore the features and architecture of the first version of our plugin designed to enable discovery by understanding the concept of a Discovery plugin. Discovery plugin is a tool which is designed to enhance the process of finding relevant content within a system by providing search and recommendation capabilities. And it is designed as a universal engine which can receive different types of input and which is defined in a specific vocabulary. And it enables an interactive discovery of resources relevant to the requirements for their potential inclusion in a data. And the generic design will allow users to integrate as they see convenient. There are three search modalities on top of an Apache Solr engine. The first one is the exploratory mode, supporting keyword and faceted exploration. The second mode is the workflow-based mode, where the input will be the query in the form of a data processing workflow. The third one is a recommendation mode, where the engine actively suggests possible complements or replacements for the resources. Now let's see the architecture of our Discovery plugin. Our plugin is built on a robust framework that seamlessly integrates with various systems, providing users with powerful discovery functionalities. At the backend, we have a PostgreSQL database, Solr indexing engine, and a CCAN, which is connected with the API and the index. And by using the Discovery plugin API, the integration tasks within UPCAST and many different integration tasks may be performed. The plugin itself, containing all the backend applications, are Dockerized and can be run with a simple command. In version 1, we implemented the search functionalities. First, the populate discovery repository in order to enable the index to have that relevant information. So we have the create, update, delete, and upload datasets function. And we have a dataset search together with a keyword search and faceted exploration. And we also have a resource search, which is a keyword. And together with that, for the recommendation task, we implemented a semantic similarity recommendation using BERT embedding. And the BERT embedding is a type of embedding which you use textual input to create a semantic vector to find similarities between two different objects. And let's start with our demonstration within the plugin. We will see the Discovery plugin version 1 API, and within version 1 we have the Apache Solr engine and all the functionalities of create, upload, delete, update, and dataset search and resource search, and recommend similar datasets. And for version 2, we are planning to have a workflow search and profiling enabled discovery. Now in the demonstration, I will first show you how to run the plugin. Then I will show you some API calls together with the CCAN user interface and their connections, and some reference user interface implementations. In here, we first define how the Discovery plugin is run. Discovery plugin is composed of a Docker Compose set of services: the Discovery Service API, the database, which is a PostgreSQL, a Solr index, and a CCAN user interface which connects these services. And you can simply run the Discovery API by having Docker Compose up command, and you have it. After running the API, you can call the API endpoints, and in this demonstration I use Postman application for testing the API definitions. We will see create, update, upload, delete, search and dataset search, and discover functionalities. Let's start by create dataset function. I give the package title as sample, and I give a package notes with a long text, and when I click send, the package is created successfully. You can simply go to the connected UPCAST CCAN instance, and that sample dataset is created here. And if you want to update the information, in this case, I update the package notes into a single word called sample, and you send the parameters, the package is updated. You can verify it by going to the CCAN instance and see the package is updated. You can upload a data within that dataset. In this case, I upload the test file to the dataset which has the ID sample. Now it is uploaded. Let's refresh, and you can simply delete the uploaded file by calling the delete endpoint. The only parameter you need to specify here is the ID of the dataset. Now it is deleted. Let's check that. Now we cannot see the sample dataset anymore. Let's go to our resource search endpoint. In the resource search endpoint, you can have simple Solr index queries, like in this example, search for the files which has a name test. As you can see, it finds the data sets with the files which has the test text file inside. And for the dataset search, you can perform more complicated queries as a Solr index query. And while doing that, you can also specify faceted search, faceted exploration, and paging together with a filtered query and sorting functionalities. In this example, I search for the datasets which has names starting with city. Let's search for it. As you can see, we have two datasets here. The first one is named city1. The second one is city2. You can change the query and apply any type of Solr queries. Let's go to our last endpoint, which is the discover similar datasets endpoint. In this endpoint, as an input, you give the dataset ID, and whatever dataset ID you provide to this endpoint, it checks for the whole index and try to find similar ones. I'm looking for weather1, and it is showing as a result weather1 as the same with 100% similarity score, and weather2 as the second one, which has 94% similarity score. You can change the dataset ID. Let's say city1 and call it again. We see city1 is the same dataset, and we also have the city2, which is the similar dataset with 86% similarity score. Together with the CCAN user interface, we also created two reference user interfaces in order to show how the Discovery plugin API can be used. For example, in this sample dataset search, you can write a keyword and search for it and get a list of results. You can specify a different keyword, search, and result. And a second one, which is again a sample reference user interface, you can give a dataset ID and check for similar ones. In this case, I'm checking for weather1 and I find weather2 as the similar dataset. I can check for city1, and again, just like the API calls we presented, we find the city2 dataset, or another one, health1 dataset, we find the health2 dataset as the similar dataset. In this UPCAST demonstration, we presented the Discovery plugin and its services. Thank you for listening.